All right. So as Abel mentioned, I'm Timm. I'm with IBM. Today, the tutorial is going to be getting started with the IBM FHIR Server. But first, I'll talk a little bit about myself. I'm a senior technical staff member and the development manager for the IBM FHIR Server. I have a background in model-driven development and code generation. I've been working in healthcare and open source since about 2008. And one of the previous open source projects that I was involved in that folks may have heard of is called Model-Driven Health Tools. So the learning objectives for today's tutorial: how do I get the IBM FHIR Server? What are my options there? How do I install and run the IBM FHIR Server? What are some of the features and limitations of the server? I'm going to talk a little bit about the modular architecture, and then I'm going to go into some detail about specific modules. I don't have time to cover all of the modules, but I'll cover some of the core modules. I'll talk a little bit about how to extend the FHIR server capabilities. We have a number of extension points. I'll touch on performance, which I think is a pretty interesting topic in and of itself that you could probably dedicate an entire talk to. And then I'm going to talk about how to get help. If you're using the FHIR server, you have questions or you run into issues. Let's get started. First things first, this is a very brief timeline for the IBM FHIR server. The project initiated in 2015. That also happened to be the year that DSTU2 was published. We were working with a client where we wanted to exchange healthcare data between a mobile application and the server. Given the background that some of us on the team had in standards and the fact that DSTU2 had just come out, we really wanted to see what could be done there. So we initiated the project. Then in 2016, we had our first really quote unquote internal release of our DSTU2 implementation. And then for a couple of years, we really were heads down. We continued to develop our DSTU2 implementation and use it for a number of internal projects within IBM. In 2019, we had really made a decision to upgrade to R4. We essentially skipped STU3, went right to R4. And then we also wanted to contribute our code base to open source under the Apache license and become more engaged with the community. Myself and some of the other folks on my team had been involved in the community, but for a couple of years there, we were notably absent. So we wanted to kind of re-engage with the community and deliver on IBM's commitment to interoperability in healthcare. And then today we have a dedicated team that continues the development of our code base in open source. We have some external contributors, and we would love for additional external contributors to engage with us and help make our server better. So how do I get the IBM FHIR server? Well, there are a few options here. If you want just the source code, you can clone our repo. It's under the IBM organization in GitHub at that link. We have a GitHub releases page where we make available kind of a distribution, a zip file that you can download and install. Even easier than that, we have a Docker image on Docker Hub. And then if you want to use the individual libraries that are provided, you can do that through our Maven artifact repository on bin tray. All right, how do I install and run the IBM FHIR server? So for the GitHub release, as I mentioned, you essentially go and download our distribution. It's a zip file. You unzip that into a directory. There's an install script in there that runs on both Linux and Windows. And you then configure the server. There is a default configuration that you can run with to kick the tires and evaluate the server. But if you want to connect to, say, a Postgres database or DB2, or you want to change the authentication mechanisms and things, there are some configuration files to be aware of, and we have information on how to what that configuration looks like in our guide. And then you run the server. It's built on Open Liberty, so it's a server start. And then of course you can test it with a health check endpoint that we created. As I mentioned, even easier than that is Docker. You can just do a Docker run and test the server. That's the quickest way to get it up and going, is to play with Docker. We support Apache Derby as kind of a database that you can use to evaluate the server and for kind of dev test activity. And then for production, we have support for Postgres and IBM DB2. So for more information on kind of installation and run, we have details in the FHIR Server User's Guide. What if you just want to use the Java libraries? In that case, you essentially configure Maven to connect to our artifact repository, and then you just declare dependencies as you would with Maven. So I'm going to touch on some of the features of the IBM FHIR Server. This is by no means comprehensive. This is kind of a high-level overview of what we support and what we don't at this time. We have a lot more detail on this in our documentation. We support, all of the core interactions. Your create, read, update, delete, view, read, history, search. The different variants of search. There's the get, post, compartment search. We support patch, both JSON and fhir-path based patch. We also support some of the conditional interactions. We have conditional create, conditional update, conditional delete. There are some built-in and implementation defined operations that we support. We have a validate and a document, a convert, apply, which is somewhat experimental, and the health check endpoint that I mentioned. And we also support the bulk data access implementation guide operations, import and export. And we support the terminology service operations. Oops. We have a notification framework that supports basic notification events on a WebSocket, Kafka, and recently we added support for NATs. We support all of the different search parameter types that are in the search spec. We also allow end users to configure their own search parameters. We support history, but it's only supported at the resource instance level, so we don't have resource type history or whole system history. For the missing modifier within search, it's not supported for whole system search or for chain parameter search. And then there are a number of search modifiers that we don't support today. A lot of these are in our backlog as things that we will support in the future, but this is based on our current version, we don't support these. So we have lots of more information on what we support. We've been building this server lockstep with the Touchstone conformance testing tool and the Inferno conformance testing tool. So we have information on that in our conformance guide, and some more information about our terminology support in our terminology guide. This is a quite simplified picture of our architecture. It's modular by design. This is not all of the modules, but these are kind of the core modules, some of which I'm going to be going into detail on. Really, it's 3 layers. We have an API layer. This is exposing the actual REST endpoints. We have a request processing layer to handle a number of different types of requests to come into the FHIR server. And we have a persistence layer below that. This is where we interact with a relational database. In our case, our primary persistence layer implementation is a relational database, but we do support the ability to plug in other technologies for the persistence layer. Then off to the side there, you see that we have our notification module, which can be used to send FHIR notification events out to something like a Kafka or a NATS or on a WebSocket. That's also an extension point that I'll talk about. So this is kind of a really high level description of the different modules. I'm going to go into a bunch more detail, but we have the FHIR model module, which is really an object model. It's generated from the R4 structure definitions. We also generate a parser for XML and JSON, and we have generators for XML and JSON as well. We have a fhir-registry module. So this is really a resource registry for definitional and knowledge artifact resources. And that's pluggable. It allows us to register resources that are shipped with the FHIR spec, but also make resources that come out of implementation guides and loose extension definitions and value set definitions and things, make those available to the FHIR server so that it can leverage them for a number of different tasks. Terminology model as well, that has a terminology service provider interface that has a default implementation that implements a number of terminology capabilities, but it has some limitations, which I'll get into. We have a fhir-profile module. This is really a module to assist in the validation of resources against profiles and to validate the content of extensions. We have a fhir-path module. This is an implementation of version 2 of the fhir-path specification. We have a validation module that uses a number of those previously mentioned modules to validate resources against the base specification and any profiles that the server knows about. We have a search module that's a utility for working with the search specification. This comes in handy if you want to implement your own persistence layer. You use the search module to help you deal with search requests, extracting search parameters from resources, and dealing with the search syntax and parsing the query parameters. We have a persistence module. This has all the interfaces for implementing a persistence layer, and then we have a concrete implementation of this for a relational database. As I mentioned, we have a notification module, and then we have a server and a client module. Really, the server module is what has our JAX RS 2.0 resources in it and some other classes for handling extended and implementation defined operations. Then we also have a FHIR client model, which is a JAX RS 2.0 compliant clients. All right, so first up, I'm going to talk about the FHIR model module. So this is a number of Java classes that have been generated from the R4 structure definitions. There are some annotations that we put on those classes. I'll show you what those look like in a second. We have constraint, which elements are required, which elements are bound to value sets, and metadata about that. Reference targets, what are the types of references? Summary, so which elements are part of a summary, and a choice annotation to give you metadata about which data types are valid for choice type elements. We have class and method JavaDoc that gets generated from the spec artifacts. We have inner classes that represent the backbone elements. And then we have an implementation of hash code equals and toString for convenience and to use the objects in sets and hash maps and things. We support the builder pattern. So from Effective Java by Joshua Block, we have implemented the builder pattern. So basically we use builders to create instances that are immutable and thread safe. We also support the visitor pattern. So each resource and data type class has an accept method. This allows us to process the tree of FHIR objects in memory using a depth first traversal, which lets us do interesting things related to validation and generation of XML and JSON and some other things, evaluating fhir-path, that kind of thing. We have some static factory and convenience methods. Another thing to note about our classes is we actually do base level validation during object construction. So we validate things like cardinality constraints and value domain constraints and kind of built-in value set bindings, required value set bindings, and some other things. We do that during object construction. So when we get a request in and we parse the payload, we actually have what we call a quote unquote validating parser, because as it's building the objects, those objects are getting validated. The other thing to note about this is it makes it harder for someone writing code using the Java libraries to create invalid objects, because it'll tell you right away if what you've built is valid or not by throwing a runtime exception. We model internal value sets as annotated Java enumerations and subclasses of the code data type. We also use the Java time library for all fire date time data types, and just kind of modern implementation that is a lot more flexible and than some previous things that were in the Java standard APIs. Here's what some of that looks like. So this is the condition resource. This is a constraint annotation on here. You can see a number of other annotations on some of the private final members of the class here, especially these binding annotations that give you some metadata about what these elements are bound to in terms of value sets, what the binding strength is, and that kind of thing. And you can introspect instances to get any of this information at runtime. And then also we have an example here of kind of our method Java doc. So we're actually generating some of the descriptions and definitions that come as part of the structure defs. And this is an example of kind of what the visitor pattern looks like. So each class has an accept method, and that allows us to perform, our depth first traversals, and you can actually control how you want to traverse based on how you implement your visitor. And we have some default implementations of the visitor to handle certain scenarios. This is just an example of using the builder pattern. This is really the pattern throughout. If you want to build FHIR resources and FHIR data type instances, use this builder. This is showing a few convenience methods for different parts, but this is creating a food intake observation with some SNOMED codes and some UCOM measurement codes. But this is the pattern. And you'll see we have some other examples, and we have a ton of unit tests that demonstrate exactly how this works. We also have a FHIR parser, as I mentioned. That's actually generated from the structure definitions as well. Can be used to parse the JSON and XML formats. We don't currently have support for RDF. We haven't had, I don't think we've had any enhancement requests just yet for RDF, but it is something we could look at in the future. And we have a FHIR generator that was written using the visitor pattern, which made it really easy to write. And that supports the generation of the JSON and XML formats. It's just a simple code snippet of parsing an input stream. You can parse an input stream or a reader into your FHIR object, or you can generate JSON or XML pretty printing on or off to an output stream or a writer. We checked the validity of the generated parser and the handcrafted generator for both XML and JSON by performing round trip testing using all of the examples that come as the FHIR spec, which I think there are a few thousand maybe. Basically reading the raw input, parsing them into the Java object model, generating raw output again, and then comparing the raw output to the raw input, and just verifying that we get the round trip that we would expect. So this part underwent some pretty rigorous testing. A couple of other useful, interesting classes and utilities. As I mentioned before, we have a number of visitor implementations to perform some different types of tasks that we use, some of which we use in our fhir-path patch implementation, some of which we use when we're handling bundles, and just other convenience classes. And we have some more information on our FHIR model module in our FHIR model guide. The next module here is the fhir-registry model. So this is really an internal registry of knowledge artifacts and definitional resources. It's pluggable, so there's a fhir-registry resource provider, SPI. We have a couple concrete implementations of that. There's a package registry resource provider for FHIR implementation guide packages. So as you may know, a lot of the implementation guide tooling that's out there produces the, I guess it's the NPM package format. And so if there's an index file and it's organized that way, you can leverage this package registry resource provider. We also have a server registry resource provider that allows you to make resources stored in your database available to the internal registry as well. This is just a code snippet of invoking or accessing the registry from Java. We have a number of built-in registry resource providers for some of the commonly used implementation guides like Karen Blue Button, DaVinci PDX Planet, which is provider directory, US Core, M-Code, and a number of other ones. And we'll continue to add to that as we see fit. There's some more information on how to write your own registry resource provider in our validation guide. The fhir-path module is a fhir-path engine that was written using code generated from the Antler grammar that's actually distributed with the spec. So there's this concrete syntax tree, or a set of classes that represent the concrete syntax tree. And so there's also a visitor of that tree. And so we leverage that to evaluate fhir-path expressions. We support the vast majority of the fhir-path 2 specification with a couple of exceptions. We have a fhir-path function registry that allows for user-defined functions. It also implements most of the functions that are part of the spec. We support the fhir-path terminology functions. Really the fhir-path engine is used in two primary places. It's used by the validator to evaluate constraints that are coming from profiles and from the base specification. It's also used by our search module to extract search parameters for indexing. We check the conformance of our fhir-path implementation using the fhir-path spec test suite. This is just a little code snippet of instantiating the evaluator and evaluating the expression, is this patient at least 30 years old? So you can use it in that context as well. Outside of the validator and the search module, you can just use it directly in your Java code in your application, depending on what your use cases are. We have a fhir-profile module. So the fhir-profile module is really a couple of utility classes that are used to really work with profiles and extension definitions. And then I think one of the things that's unique about our implementation is kind of how we handle validating resources against profiles. We actually have a constraint generator that generates fhir-path constraints from a profile or an extension definition. So you start with a structure definition as input to the constraint generator. And what happens is it essentially organizes all the element definitions that are in the snapshot into a tree using the element definition ID. And then it goes through the tree looking for constraints. It supports a number of different types of constraints: cardinality constraints, choice type constraints, constraints on the type of reference, extension constraints, various terminological constraints, and then value constraints for fixed and pattern value constraints. We don't support all the different permutations and possibilities that are there, but we really support the majority of the types of constraints that you would see in most implementation guides. Then we prune nodes that are in the tree that we created that don't have constraints or children with constraints. Then we go back and we traverse that tree again, and we generate fhir-path expressions or conjunctions or disjunctions of fhir-path expressions for each of the constraints that we find in the tree. So this is leveraged by the validator to actually validate that our resource instances are valid against whatever profiles are configured for the server. So if the profile is configured and available through the internal registry, we can pick it up, we can pass it off to the constraint generator, we can generate the fhir-path constraints, we can cache those, and then we can use those to validate resources that come in that assert conformance to that profile. We have more information on this in our validation guide. As I mentioned earlier, we do have a fhir terminology model. It does have this service provider interface. It supports the expand, lookup, validate, code, closure, subsumes, and translate functions. We have a default implementation of the fhir term service provider. And so this is kind of our, right now, this is one of our limitations, is if you have a value set with inline concepts, or you have a value set that includes or excludes concepts from code systems that have content equal complete, then our default terminology service provider implementation will work for you. Also, if you have a pre-expanded value set, it'll work for you. What it doesn't work with is code systems like, say, SNOMED that doesn't actually have the content defined in line. But I will get to proof of concept we did that will eliminate that limitation. We have some other utilities for working with terminology artifacts. So code system value set concept map, implementation of the expand algorithm, for example, for value sets. This is just a code sample of how you would use the FHIR term service singleton to perform a lookup operation on a coding and get a lookup outcome. More information on that and some additional details in the FHIR terminology guide. All right, FHIR validation. So all those previously mentioned models kind of come together and are used in this FHIR validator. FHIR validator is written using the visitor pattern, as I mentioned, which makes it really easy to process these trees of FHIR objects. And it leverages fhir-path, fhir-profile, and FHIR terminology modules. It allows us to perform validation on constraints that come from the base specification, constraints that are specified directly in profiles, and constraints that are generated from profiles and extension definitions, and also vocabulary constraints. This is just a simple example where I built a patient resource and I instantiated and invoked the FHIR validator on that, and I get back operation outcome issue instances. And the reason why that's interesting is because then we can actually build an operation outcome when we're using this in the context of the server, or you can just use it like this directly in Java. We have a validation guide that talks a little bit more about this. All right, I want to talk a little bit about some of the ways that the FHIR server can be extended. So we have the FHIR persistence layer, one of the major 3 layers that we have in our architecture. It allows you to actually plug in your own custom persistence layer and configure the FHIR server to use it. We have a guide called Bring Your Own Persistence Layer if you're interested in what that means and how to do that. We have what's called a persistence interceptor. This is a mechanism that can be used to execute your own custom business logic within the main request processing flow. So before or after a create interaction, a read interaction, update, delete, etc., you essentially create a FHIR persistence interceptor, you package it into a jar, you drop it into the user lib directory, and your FHIR server will start up and pick that up, and it will execute your code in the main processing flow, main synchronous request processing flow. Again, notification framework, you could create custom notifiers that will write FHIR notification events out to somewhere like message queuing technology, JMS or something. We have support for NATS, for Kafka, for WebSockets. A FHIR operation framework. So this is where you plug in to create your own custom operations. So these would be what the spec calls implementation defined operations. One example of that is our health check. And we've created for a number of projects, custom operations that we plug into our server for a number of different use cases. fhir-registry resource provider. So this is how you would make FHIR definitional and knowledge artifact resources available to the internal FHIR registry. That's also pluggable. If you want to replace our terminology service provider or override our default terminology service provider, you can write your own implementation of a custom terminology capability and plug that in. This could be call out to some remote terminology service, like an Apollon DTS or something. You could call some other FHIR server, like a public endpoint for SNOMED or Loink. And really the FHIR terminology service is the design is really for the providers to advertise what code systems they support. And then when a request comes into the terminology service, it finds out which terminology service provider should be used to handle that request. That's the design. And it's still somewhat in development, I would say. And I'll talk a little bit more about kind of what the future of that's going to look like. We also have a fhir-path function registry, so you can extend the behavior of the fhir-path engine by plugging in your own user-defined functions. Performance. So I'm just going to briefly touch on this. So our approach really has been just continuous performance testing and improvement. We're very fortunate to have a performance engineer on our team. From really early on, he joined our team, and he really got us thinking about performance, really shifting things left and identifying and addressing performance issues early, and thinking about performance in our design. And there are a lot of challenges associated with performance, especially when you're using a relational database and you're building relational queries on the fly. You can certainly optimize certain types of queries, but because the search spec really allows for this very rich ad hoc kind of query language, there are still challenges. And so this is something that we're constantly working to improve. We recently published an evaluation of our performance using the synthetic math data set. We basically pulled down the 1 million patient data set and loaded our server with it, and then did some testing with a number of different types of workloads. So we have a report on there with some nice graphs. So you can go check that out and see where we stand in terms of our performance for those types of workloads. We've also done a little bit of micro benchmarking as well of individual modules. So looking at comparing some of our modules like our parser, generator, validator, fhir-path engine against other implementations to see kind of where we sit. All right, how do I get help? So you've downloaded the FHIR server and you've installed it and you're running it, and now you're evaluating it and you're doing some things in dev test with it, and you have some questions or you've run into an issue. We have a Zulip stream that you can go to. We have some documentation in our GitHub web pages. So we have the first link there, which has a guide section, which has a number of different guides, all of which were linked in some of my previous slides. And we also have a developer wiki. So this would be for someone that wants to contribute to the FHIR server and set up their environment, in Eclipse or whatever. This is where you'd go to get that type of information. And then we have of course, our GitHub issue tracker. So any enhancement requests or bugs that you run into, you can report there. And like I said, we have a dedicated team. We're very active in squashing bugs and prioritizing and planning for enhancements. So we're pretty responsive in that regard. And then also we have some generated Java doc. So all those Java doc comments that went into our generated classes and the method Java doc, that all gets put into a really nice Java doc package that has UML diagrams and things. So that's a place to look as well. So what's next? Well, we have a backlog of enhancement requests and bugs that we continue to work at and to triage and to prioritize and put into our sprints. And I encourage you to take a look at that. We have labeled some of our bugs or some of our feature requests as good first issues. So if you're interested in contributing to our project, you can go look out for those labels, and we're very willing to help anyone get started if they want to help contribute to this project. We continue development of a horizontally scalable persistence layer backed by a key value store. We started to look at Apache Cassandra and Foundation DB. Although our primary persistence layer is implemented on a relational database, we have implemented on some NoSQL persistence, like a document-oriented persistence layer with CloudInt. We've also looked at we've actually built one on HBase. So we're familiar with what it takes to build, build a persistence layer, and we know what the trade-offs are. But right now we're looking at a key value store to get around some of the kind of scale up limitations that a relational database has. And then we're also looking to build out a more robust implementation of the FHIR term service provider based on prototype that we put together using a graph database. So we had some previous experience a while back using a graph database to represent terminological content coming from places like UMLS and NCI Metathesaurus. So we did a prototype of that, and that's something that we're going to be pushing out into open source probably towards the beginning of next year at this point. So that's kind of where we're going in a nutshell. So looking back at our learning objectives, we talked about how to get the IBM FHIR server, how to install and run it, some of the features and limitations. We looked at the architecture, which is a modular architecture, and then we went into detail about some individual modules and what they can do, how they contribute to the function of the server, and how to use them from Java. And we talked about a number of places where the FHIR server can be extended, touched on performance and how to get help. So if you want to contact me, I know we're kind of in our last day of DevDays here, certainly shoot me an email. You can check out my profile in the speakers gallery as well. Or you can go to any of those other places I mentioned, like our IBM stream on Zulip. We look forward to talking to you. And now I think, Abel, if we have any questions in the Whova app, I'd be happy to go ahead and answer those now. We have about 8 minutes left.
Yeah, we have about 8 minutes. I already saw it. I have a question. The question is, can you give a short overview on access authorization? How do you secure stuff on resource level and search query level?
That's a great question. So we support a number of authentication and authorization methods. We actually, authentication-wise, we kind of support what Open Liberty supports out of the box. So this is your basic auth or mutual TLS. But we also support Smart on FHIR app launch sequence, which we needed for the CMS regulations that came out on patient member access. We support the enforcement of authorization scopes that come in on a JWT. And I believe a member of my team, Lee Surprenant, was involved in a community discussion about using Keycloak as the authentication and authorization server for that. So our most recent foray in that area has been using Keycloak as the authentication authorization server, and baking in support for handling JWTs.
Okay, that sounds like a great answer. I don't see any other question at the moment, but I have a question myself, if it's okay. I was just wondering, what was your biggest challenge when you developed your server?
Well, I'm going to have to go with the persistence layer and really performance in conjunction with implementing the search specification. There are so many trade-offs we actually, our first persistence layer implementation was using JPA and a relational database, and we found that the performance was terrible.
Yeah.
Then we looked at using a document-oriented data store, which is Cloudant, which did have some ad hoc query capabilities, but the trade-off there was we didn't get, we didn't get to implement all of the search features, just because usually your document-oriented databases don't have good support for things like joins, and so that was a challenge. Plus, that was actually built on Lucene. At least the version we were using was built on Lucene, there are just some inherent limitations on using Lucene to do very complex types of queries. So we ran into really an issue there with implementing the features we wanted, but also also the performance turned out to be pretty bad. With HBase, which is columnar, that had great performance for some of the core interactions, but was extremely limited, even more limited in terms of what you could do with search. So that was, we enabled the use of what we called composite search parameters, and we had kind of two HBase tables, and one that stored the resource and allowed you to do your read and your history, and then another table that was kind of like the quote unquote index, and allowed you to do fast lookups of certain combinations of search parameters, but it was very, very, very limiting. Then we had a performance engineer join the team, and he came in and he kind of revamped our entire schema, and that gave us much better performance, and came in and helped us figure out the best way to index, store and index the data. But I think we're kind of at a point now where we're really at the limits of what a relational database can do, especially when you start talking about millions and millions and millions of records, and you start to get really big index counts. And sometimes you want to do something like a join in Postgres, and it doesn't make a great plan, and it doesn't make a great execution plan, and so you get some types of queries that, like with reverse chaining and includes and things, where you just don't get the performance you were hoping to get. So that's kind of like that was definitely our biggest challenge. And we continue to work at it. And as I mentioned, we're looking at alternatives. We're looking at key value stores, and bringing in potentially graph databases and things. So
okay, yeah, that's interesting. So let me see if there are any other questions at the moment. No, I don't see any questions. Let me look, because sometimes it's not refreshing. No, not at the moment. So if anyone feels like asking another question, you can ask it now. You can also ask it afterwards if you want to. John will probably scoop up the questions when he's done with this afterwards. See if there's anything to answer for him. But you can still ask a question at the moment if you want to. Still watching.
And we have a chat stream on our exhibitor page. You can ask questions there if you want. You can go to Zulip and ask questions there. Whatever is most convenient.
Right. And do you want to call for people to join your project?
Yes, we obviously we have a dedicated team within IBM, but we have had some external contributions, and we would love for other organizations to come in and help us work through our backlog, and add some enhancements and improvements, and really support additional use cases. We're getting enhancement requests all the time, and I think that's great. But given the team we have, we prioritize things and we work through them at the pace that we can, but certainly having external contributions can help to accelerate that.
Yeah, sounds perfect. Well, there are no other questions, John, and we have like a half a minute left. So I would like to thank you very much. It was a great presentation. And also want to like to thank all the participants, the people who watch. We will see you guys later on today, and of course we're already done with DevDays. But have fun with the last few presentations. Goodbye.
Thank you.